Yep. Hello, welcome to the 2023 Level 1 TIG exam walkthrough. Let's get right into this. Give the equation of the graph shown below. So basically, let me get my notes. So basically, we can observe that this is a linear line of y equals mx plus c. So we can do rise over 1, pick this point here, as we go across 2, it goes down by 5, down 5 across 2, so the gradient is m is equal to negative 5 over 2. And then yeah, we can just do y equals negative 5 over 2x plus c. We can't see where the c intercepts somewhere, but we can plug in the point 6 0 0. Plug in the point 6 0 gives us 0 is equal to negative 5 over 2 of 6 plus c, which is c is equal to 15. Y is equal to negative 5 over 2x plus 15. Find the equation of the new line if the graph shown above is reflected in the y-axis and also shifted 10 units vertically upwards. So if this is reflected in the y-axis, like across here, then this graph would just have be a linear graph this way. So, and this is just a positive gradient, which goes in the rise over 1 will be 2 to the right and up 5 upwards. So the reflected gives us y equals 5 over 2x plus 15. And also shifted 2 units vertically to the up. So if it's shifted vertically upwards by 10, we add 10 to the constant. So equation will be y is equal to 5 over 2x plus 25. Find an equation that would model the height of the chain. A city council plans to create a fenced grass area in the Infantile region. So if they decide to install some posts with a chain fence between them as shown. Right, the distance between the inside of each of the post is 120 centimeters. The chain was attached to each post 45 centimeters above horizontal ground and hangs symmetrically. The lowest point on the fence is 36 centimeters above the ground. One section of the fence is shown in the diagram. Find an equation that would model the height of the chain between the 2 points as shown in the diagram above, where x is the horizontal distance from the inside of the left-hand post and h is the vertical height of the chain above the ground. Right, the x-axis will be ground level, and the h-axis will be in the line with the inside of the left-hand post. So right, yeah, we can use this with, we can graph this by with ax squared in the form of a quadratic with ax squared plus bx plus c, and there is the form called vertex form, which is a of x take away h squared plus k. I might have the k and h the wrong way around. Yeah, this h is the x point of this lowest point, and this k is the y-axis of this turning point. So the turning point is 60, 36. So h equal to a constant times x take away 60 squared plus 36. To figure out the constant, we could just plug in this point 0, 40, 0, 45. So 45 is equal to a of 0 take away 60 squared plus 36. 9 is equal to 3600. A, which gives a is equal to 1 over 400. H is equal to 1 over 400 of x take away 60 squared plus 36. Yeah. After reviewing the design, the council decides that the lowest point of the chain should actually be lower than the design shown. The posts cannot be moved or changed as they have already been installed, but where the chain fixes onto the point would be changed if required. Suggest at least one way in which the original equation of the chain fence design could be altered to make chain hang lower, but with the chain being in the same shape as the original chain. Right. But with the chain being in the same shape. Chain being in the same shape as the posts. Fence guy. Right, so the posts are here and here. The posts cannot be moved or changed as they have already been installed. So suggest at least one way in which the original equation of the chain fence design. Let me see my notes a bit. Sorry, I was like reading it. I was like being very illiterate, so that's why I was slightly struggling on this question. So describe how you suggest at least one way in which the original equation of the chain fence design could be altered to make the chain hang lower, but with the chain being in the same shape as the original chain. So for the chain to be in the same shape, we need this constant a to stay the same. So for shape to be the same, constant a is the same. The constant, for example, in a graph, this will be, for example, if this is y equals x squared, then a graph like a much narrower graph like this is y equals 2x squared, and having a graph like this will have y is equal to half x squared, and this constant in front will change how wide the width of how wide or how narrow the quadratic will be. So we're not changing this. For the chain to hang lower, change the constant to a lower value. So if we change this plus k here to like plus 18, then this will be here. Or every point will be translated below by 18. So lowering the constant will decrease the whole not decrease, translate the whole graph down by a certain value. For every point on the graph. So new equation will be y is equal to 1 over 400 x take away 36 squared. Right. At least one way in which first, yeah, changing this x value would only translate side to side, so it would not change how high the chain hangs. Plus k, where 0 is between k and I think 36, yeah. 36. The new graph will be translated down by 36 take away k. One side of the reserve has trees along, and this side will not be fenced. The council has a budget to purchase only 240 meters of materials for the total of the other 3 sides of the rectangular grass area, as shown in the diagram below. Using tables, equations, and graphs to investigate the relationship between the length and the width of the grass reserve and the area enclosed by the fences, provide at least 3 different comments that follow from your investigation. So we're given that this side be A, then this side is also A, and this bottom side is B, and we're given that the sum of this will be 240. So 2A plus B is equal to 240, and the area will be given by A times B. So 2A plus B, this can be rewritten as B is equal to 240 take away 2A. We can replace this B into here. So area is equal to A times 240 2A. Yeah, this, I don't understand how. Do I need to use tables for this? I don't know why I would need to use tables for this. How many spaces do I have? 1, 2, 3, 4, 5, 6, 9. Alright, like 6 feet. This is so this is the area. Right, no. This is the base. This is this is side A, side B. So basically this means A is equal to 0 and 120. And we're also given that means B, the solutions of B are 0 and 240. So this is equal to 240 a take away 2a squared. This is a quadratic. Let's graph this on a quadratic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, this is 12, I think. So 121. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, okay, yeah. 20. Actually, no, I think it's to graph this, actually. So, so yeah. Let's graph this. Yeah, I think this table is just for graph, actually. So let me just so the equation was 240 x take away 240a take away 2a squared. So if a is equal to 2, 3, 4, 5, 6, 7, 8, 1, 2, 5, 6, 7. Okay, so there's 8 spots. Yeah, I'll just do 30 each. Actually, it can only be like multiples of it's only between 0 and 120. So okay, so if a is 0, then area is 0, then side length b is 240. Then 2, 3, 4, 5, 6, 7, 8. So if this is 15, then if this is 15, this is 3,150. If a is 30, then 5,400. 45, then 6750, 45. 60, then 200. I think it just goes downhill again. Yeah. Then this is a quadratic, so it's just symmetrical. So here to here, here to here, and here to here, due to symmetry. 75, 90, 105. And the side length B will be B is 240 take away 2A, 210, 180, 90 is 150, 120, 90, 60, 30. So let's graph this. To the height 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. is a bit annoying to draw. Okay, it's just it just says it increases by no, my brain's not braining today again. So if it's 7,200, let's just go up by 1,000. 1,000, 2,000. Oh wait, no. Actually, do I want to? 15. That's probably enough for 500 times 15 is 7,500. So yeah, that's enough. 1,000. Let me write that a bit more cleaner. I need to improve my handwriting. 1,000. 2,000. 3,000. 4,000. 5,000. 6,000. 7,000. Okay, so in side A is 0, side A is 15. But this is side A, then here is area. Side A is 20, 10, 15. So when side A is around here, then the area is around 3150. 3150. So around here. Means side A is 30, area is around 5,400. 10, 20, 30. 5,400. 45. 30, 40, 45. 45 is 6750. 6, 5. 45 is around here, then 60 is 7,200. 45, 50, 60. 7,200. Then it's symmetric, so we could poke one here. Poke one here. Poke one here. And yeah, let's just draw the graph. I'm so bad at drawing. Right, this should be right. 60, 75. Yeah, that should be symmetry. Wait, this should be 60. This is 60. Yeah. Okay, yeah. 10, 20, 30, 40, 50, 60, 70, 80, 90. Oh, wait. This is... Oh, I messed up. No. 10... 60, 65, yeah, Okay, here is 120. So here we go. So we can clearly see that here is the max. So okay, so my comments are, the comments I wrote down were so okay, so the length A is restricted between 0 less than A less than 120 and length B is not represented, restricted to 0 less than B less than 240. Area is maximum at A equals 60, B is equal to 120, with max area is equal to 7,200 meters squared, and the area and fence with A and B can be represented through a negative quadratic. Give the equation of this graph shown below. So again, we could use the vertex form y is equal to a of x take away h squared plus k. We can see the vertex is here, so at 3, 6. Vertex 3, 6 is equal to a of x take away 3 squared plus 6. Then let's just choose this point. So we're given that 0, -3 is a point. -3 is equal to a of 0 take away 3 squared plus 6. 9 is equal to 9a, which implies is equal to -1. So is equal to negative of x take away 3 squared plus 6. Using the set of x's below, provided below, draw the two graphs y equals 2x take away 3 and y equals 2 to the x take away 3 and y equals 2x take away 3. Wait. Okay. Appears this does not. I don't need a text box. Do I have any? Seems like I don't have any utensils. I need to draw it by hand. So other applications have like a ruler and stuff. So yeah. Y equals 2x take away 3. So -3 is the intercept, and we go up by 2, and so on. So here, so you definitely need a ruler for this. You should have used it for this. Up here. This should be like more straight. Yeah. Then y equals 2 to the x take away 3. So it goes from 1 to then 2, then 4, then 8, then 16, and yeah, this goes all the way to 0. Then here, and just all the way up. Wait, they never intersect. Have I done wrong? Oh wait, no, I think I... Oh, no. I'm sorry. So, y equals 2 to... is equal to 2 to the x take away 3. So we're... x equals 3. This goes y equals 1. X equals 4. Equals 2. Y equals 2. X equals 5. Y is equal to 4. X equals 6. Y equals 8. Equals 7. 7y equals 16. So where y is equal to x equals 3, y equals 1, 2. Here it will be half. Then it keeps on doubling. I mean, going up by a factor of 2. So and this keeps on approaching 0, but will never actually reach 0. Using a graph to solve the equation 2 to the x take away 3 equals 2x take away 3. We just eyeball it, so we just guess that the intersections are here and here. So just eyeball it and say by inspection the solution so that looks like around 1.6, no, 1.7. That looks like and around 0.5. And the other one seems like around 6.2 and around like 9.3. I don't know. Solutions are 9.3. I put it in the calculator and yeah, it said okay, the calculator, I put in a calculator before, and it says the solutions are 1.7. Yeah, real solutions. 1.7, 0.41, and 6.25, and 9.49. Those are the real solutions, if you are curious. Adam is looking at the number of followers on a particular tree in his garden. He counts the number of flowers on each level of branch on the tree. Branch level 1 is the branch closest to the ground. Branch level 2 is the next one up, and so on. The table below lists the result of his research. Yeah, okay. So we can just always see the difference. So here is 10, 14, 18, 22, and the difference between is 4, 4 and 4. If it's like always in the if this second arithmetic difference here, like this, is always the same, then it's a constant, then it's always in the form y is equal to ax r, in this case n squared plus bn plus c. But yeah, let's complete this here. It'll be the next sequence will be plus 26. Then the next sequence will be plus 30. So 126 plus 34, which will be 160. Using the axis below, draw the graph branch level in number of flowers on that branch. So we're given that 1 and 6. N equals 1 implies 6. Wait, do I need to... Wait, let me look at my notes again. Okay, no, I don't need... Yeah, okay, yeah. I don't need to... Yeah, this is a discrete graph, so yeah, I don't need to connect it. So we're... Branch is equal to 2, then it is 16. Branch is 3, it is equal to 30. Then 48. Then 1796. 96. 126. 160. Find an equation that represents the number of flowers on any given branch. Justify your answer with clear working, including appropriate domain. So if the difference is 4, then usually the a value is that difference divided by 2, which is equal to 2. So y is equal to a n squared. Actually, this just is the second difference. Actually, it's the difference of the initial differences are constant, and yeah, we're given that a is the constant is 4. Constant is 4, so we have a is equal to 2. So basically, if we go back, this will be this will be plus 6. So initially it will start with 0. So y is with a 0, b of 0 plus c. This y is also equal to 0, which implies c is equal to 0. So actually no. So I used the incorrect. This is not y. This is if. So if is equal to 2n squared plus pn, as c is 0. Then we just plug in a random constant. So if of 1 is equal to 2 of 1 squared plus b of 1, which is equal to 6, b is equal to 4. So if n is equal to 2n squared plus 4n. Let me check my notes. Yeah, that seems correct. Adam counts this number of flowers on each level of branch and of branch on a different tree. Find an equation that represents the number on any given branch on the second tree, justifying your answer. So it's times 4 from here to here, times 4 times 4 times 4. So these multiply by 4 again. So 256 times 4 is 1024 times 4 is 4096 times 4 is 16384. Find an equation that represents the number of flowers on any given branch on this second tree. So flower is equal to so since it because if n increases a factor of 4 each time, if of n is equal to 4, f of n take away 1, and because the initial branch level 1 is 1, so we need the 4 n take away 1. 4 to the n take away 1, yeah. Adam claims that this formula will help him predict the number of flowers on trees in New Zealand. Comment on this claim, giving at least 2 different statements to support your answer. So my first comment is that so Adam could be quite inaccurate. So my first comment is that this could not be the case. For every flower branch is he only tested one branch with different levels. The second comment I mean this is kind of similar, but I had no idea what to add on, so assume that branch level increases by a factor of 4. Give the equation. Yeah, that I really dislike these vague, like this question, and yeah, these questions I really dislike the vague the vague question that just says comments. It's like, I'm not too sure what to comment on those. Okay, thank God I'm recording. Give the equation of the graph shown below. So, the graph here is y is equal to a times b to the x plus c. We can kind of see that this approaches 0 for -4. So c is equal to -4. Y is equal to a of b to the x, take away 4. We're given the point 0, 0. So 0, 0. So 0 is equal to a, take away 4. And a is equal to 4. Y is equal to 4b to the x, take away 4. It's now I test this point, so 1, 4. This implies y is equal to, oh no, 4 is equal to 4b to the 1, take away 4. A is equal to 4b, b is equal to 2. Therefore, y is equal to 4 times 2 to the x, take away 4. Yep, that seems that. I don't want to write 42. 4 times 2 to the x. On the axis below, draw the graph 3y take away 2x plus 6 equals 0. 3y take away 2x plus 6 equals 0. 3y is equal to 2x take away 6. Y is equal to 2 over 3 take away 2. Take 2 over 3x take away 2. So here is 2, and the rise over 1 is 2 to 3. So rise is 2 for every 3. 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 So yeah, okay. Yeah, draw it accurately with a nice ruler. That is my tip with it. This question. Bronwyn plans to invest $1,000 using her bank. The bank offers 3 different types of savings plans, and she needs to decide which one to choose. She wants to compare how her savings will increase over the next 6 years. The details of each saving plans are listed below. Bronwyn does not plan to take out any money during the 6 years. Now, all graphs in this question can be considered to be continuous. Savings plan A, invest $1,000 at the start and then receive the same regular payment of $250 at the end of each year. The equation for savings plan B is modeled by the formula 60t squared plus 10t plus 1,000, where t represents the number of years since Bronwyn started her savings plan and s represents the total amount of dollars in Bronwyn's account. The details of saving plan C are shown in the table below, which can be modeled by an exponential equation of the form S equals P times Q to the T, where P and Q are numbers to be found. T represents the number of years since Bronwyn started her savings, and S represents the total amount in Bronwyn's account. The graph of savings plan C has already been drawn for on page 15. The equation for the savings plan C. S is equal to P times Q to the T. 1,000 is equal to P times Q to the 0. This is equal to just P. So then we are given that S is equal to 1,000 times Q to the T. We're given that 1,200 over 1,000 is equal to Q, which is Q to the 1, which is equal to 6 over 5. Is equal to 1,000 times over 5t. let's go. Draw the graphs that models the savings plan A and savings plan B below. Yeah, I think this is easier. So wait, we're given. I think doing the next question is easier, so I'll do that question first. So we're given that we invest at this $1,000 at the start, and then receive the same regular payment of $250 at the end of each year. This just means it's always a constant of $250 per year. So S is equal to 1,000 plus 250 T. Is equal to 1,000 plus 250 T. This is for 1. Is equals 60T squared plus 10T plus 1,000 for 2. And S is equal to 1,000 times 6 over 5 to the T. This is 3. It's A, B, and C. Doesn't matter. 1,000, 1,250, 1,500, because, yeah. 1,000 times 1, 1,000. Yeah, this is just 1,000 plus 250 times 0. 1,000 plus 250. 1,000 plus 250 times 2, dot, 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 and so on. So 250, 2,000, 250, 2,500. Savings plan B. Okay, yeah, no. I think you just plug it into a calculator, like, original is 1,000, then 60 plus 10 plus 1,000, which is equal to 1,060, I think. Oh no, 1,070. 1,070, then, yeah, do this for all of it. Yeah. 1,260. 1,570. 2,000. 2,550. I'm guessing you don't have to show your working for this. 220. Okay, then, yeah, I think it's easy to graph this. Remember the first one is just a linear graph, so 1,000, 250, 3,500, 550, 1,000, 2,000, 2,500. Yeah, so let's just draw straight graph. Here, and then let's draw 10, 7, T, 1260, 1570, wait, no, that's definitely not, wait, actually, yeah, let's pull it around here. 2,000, which is, let's see here, 2,550, and it's just above here, 3220, which is around 3,220. So yeah. This is a bit of a huge graph. Is this accurate? 1,000, right? 1,260, 1,000, right? 1,579 should be around here. Okay. Then 2,000, then 2,550. Okay, that's still a bit annoying. Still seems a bit weird. Okay, that, yeah. Provide at least 3 comments that follow your what? Oh, okay, thank God. Thank God, okay. Okay. Let me try it. Let's compare like the intersection of here and here. Okay. Actually, so my first comment is for the first 3 years. Wait. Does this match up? Okay, yeah. For the first 3 years, savings A is the best. Yeah, okay. I'm guessing it wants us to compare this first part where savings A is the best, then the second part where savings C is the best, and the third part where savings B is the best. Provide at least 3 comments that follows. For the first 3 years, savings A is the best, and for the first and gives and I don't know, gives saves the most money out of the 3 savings for years 3 to actually yeah, it gets added at like the end of the year, I think. So for years 4 to 5. Savings C is the best. For years 6 and yeah, it seems like 6 for years 6 and beyond. Savings B seems to save the most money. I'm guessing this is the main thing we want. I'm gonna add some other things to be safe. So, right, using tables, give a detailed comparison between. Okay, so best is nothing. A C C. Oh, wait. No. This point is supposed to be. There's a point that's supposed to be around here. I don't know how I messed that up. To be around here. C's. Oh no. Yes. For is 4. No. For year 4, savings C is the best. For is 5 and beyond, savings B seems to save the most money. Saving. Okay, I'll just write other comments with it. They intersect. So A and C seems to be the best. Yeah. 3.2. Saving B and C seem be the best. Yeah. This seems to be a yeah, 4.9. Yeah, okay. I'm guessing these. Yeah, okay. My hypothesis is that these comments are what you need for A, but yeah, having other comments like this is probably good to strengthen your evidence. Yeah. Okay. Now people want me to go. Actually, I want to rant about one question, but before that, I will. Yeah. So this is probably a question. Surely this is a. Okay, this is a M. This is probably an E. And this is probably also E. This seems like a or maybe a M. Actually, this is different. Uh, okay, we can. This is a E. Maybe. Actually, no. Okay, no, I changed it to M. This probably is a M. Then maybe this is a E, and these are combined. These are combined A questions, maybe. This is probably a A. Hmm. Actually, no. I changed this to a. I changed this to a E again. Actually, this is a E, and yeah, this becomes combined A and M. A M E. This is A. Actually, no. This is definitely a A. We can. This is a. This is a M. At least we can. Show this icon A, and yeah, this is a M E question. Okay, and yeah, okay. So the tutorial is over, but I want to rant about. I mean, yeah, the walkthrough is over, but I want to rant about one question. So for this question, I'm guessing they want us to graph it with the quadratic of height is equal to a of x take away h squared plus k. But when you have hold a chain like this, these chains are always in the form h is equal to a of cos of hyperbolic cosine. Like when you hold a chain, although it looks like a quadratic, these are actually modeled by hyperbolic cosines. So technically you can answer this, but yeah, I would not risk it. But yeah, it's just a bit interesting to see how this hyperbolic cosine function of e to the x plus e to the negative x over 2 models this function. Models when you holding a chain like this. But yeah, I guess this finishes it. Thank you all for watching.